Let's look at feathers. Yeah, we haven't got to the bones yet. Okay, feathers. This is a contour feather, okay? And you guys have all played with a feather before. When you go like this, there's a lot of resistance, isn't there? And so feathers, and you guys all know how light feathers are. They're very, very light. And yet there's a real interesting construction to the feathers where they have these barbs, and then they have barbules, and they hook together. And that's why, like up here where it's open, you can see where it's open. That's because the barbules aren't hooked to the barbs and the barbules aren't hooked together. And so what will the bird do? You tell me, what does a bird do to take care of that problem? He preens, actually, he preens. So there's a oil gland above its tail, and it'll rub its beak in the oil gland, and then it'll go like this until it actually is able to reconnect them. What's very interesting is, I had a student years ago that his dad had a cockatiel, and he would take all the feathers that the bird would molt and leave, and he would go like this until they actually reattached themselves. He could make an ugly feather look pretty again. Now, he was very patient. He would just sit there and stroke it, but it really struck me that he was able to do that. I'm trying to see here if I have a down feather, but yeah, there's one. Now, that's a contour feather that I just showed you with the hooks and the barbules. Nope, that's not one. There's your contour feather. A down feather doesn't have the attachments where they hook to one another. So you tell me, what is that used for? Because it would just be a really bad hair day for the bird if he looked like that all the time.
Heating?
Heating, is that what you said? Yeah, insulation? Absolutely. It's used for insulation. So you'll see these down feathers underneath the contour feathers. The contour feathers tend to be for flight, and the down feathers tend to be for insulation. Although birds like ostriches, they have down feathers because they don't fly, do they? So they just kind of run around and drive people crazy. Okay. The other thing I wanted to point out about a feather is a feather grows out of a follicle like hair does. And this is important because the evolutionists want us to believe that the reptiles evolved into birds, but that would mean scales had to have evolved into feathers, and they are not at all similar. Not at all similar, okay? Because actually feathers are more like hair, like I said, where they grow out of a follicle. If you've ever plucked a dead chicken or a dead bird, you know what I'm talking about, where you've got to really grab them and pull them out. So it's more like a hair in there. Oh, can you tell I've done that? My brother made us do that one year for Thanksgiving on his turkeys. I said, I can do without turkey. I really don't need turkey. I'm not doing that again. That was miserable. Anyway, kudos to any of you that do all that stuff because you're trying to be healthy. It's just too hard. I'd rather be a vegetarian. It's just easier. But they're really stuck down in, whereas scales on the skin is just a surface area. It's over the surface. It's not embedded in. So it would be very difficult for those to evolve one to the other. I found it interesting that when you look up feathers on the internet, if you're really studying these, there's several different types of feathers. From your flight feathers, which would be your contour feathers, all these weird things in between down to your down feathers. Thank God we don't have to know that, right? Okay, and is there anything else we're supposed to know about feathers? Let's just make sure here. The down feathers, it said, lack the hooks and barbules, whereas the contour feathers have the hooks and barbules. They provide strength. They're very flexible at the fraction of the weight, and so they help them. And I've got it. The reason that a bird is able to fly, just the simplified version, is called the Bernoulli Principle. And that is this. When you have this shape, which if you took a bird's wing and cut it this way, or if you take an airplane's wing and cut it this way, they're shaped just like this, okay? Have you ever wondered how that thing that weighs tons and tons and tons can get into the air? This is how. And they took it from the birds. So God made this shape on the side of the bird's wing. Well, what happens is, as the air passes over it, this air actually has to move faster than the air underneath it because it's got to go farther in the same amount of time. And I heard on one place on the internet, it actually said that the air is compressed, kind of like if you were in water, like in a little river, and then you got in an area where the water's traveling through, but it's a more narrow area, you're going to go faster, aren't you? And then when it widens back out, you're going to slow down again. Well, they said that's what the air is doing because the air is fluid. So as it's going here, it's being squeezed, so it goes faster. And then here, it's going slower because it stays more spread spread out. Well, what happens when you have that is something called lift. And lift, because of the low pressure over the top, will actually make things come up. Let's see. Does anybody have, do you mind if I borrow your piece of paper for a minute?
Sure.
I'm going to blow on it. Is that okay? Thank you. Okay, so watch. If I blow across the top of this, see it come up? Now I'm blowing across the top of it. You see that? Thank you very much. That's the Bernoulli principle. That's lift, because when you go faster, the air goes faster over the top than the bottom. It actually pulls whatever it is up, and that's how airplanes get up. If you've ever wondered and sat on the thing and said, how does this thing get into the air? That's how. Okay. Now the other thing is, oh, this was good. I got to show you this. Remember, I talked about the bird. They found that when they built planes, that the turbulence almost ripped the planes apart, and in some cases it did when it was landing. And so they looked back at the bird again. I'm on page 512, and they saw the alula, and the alula are these little flaps on the front of the bird's wing, and they didn't know how they worked, but they added them to the airplane wings. And if you've ever sat on the wing in a commercial flight, you've seen that part come out when they're taking off and landing, I'm pretty sure. But the point is that got rid of the turbulence and made it much easier, and they didn't know why till much later. They just copied what they saw in God's design, and it has to do with how the fluid moves over the wings. So I wanted to show you this other part. This was cool.
Hey, it's me, Destin. Welcome back to Smarter Every Day. So some of my favorite things to learn are those things that I've seen for several years, and I've made a lot of observations, and I kind of think I get it, you know? I mean, like,
he lives in Alabama.
And then I find out I don't.
Can you hear him?
So when I first saw what I'm about to show you, it blew my mind because it was so simple. I should have seen it my entire life, but I didn't. Look at this bird. The muscle that flaps the wing is here toward the center.
I think he's an engineer.
It pushes down on the wing. But the feathers going out towards the edge of the wing are overlapping in such a way that they all push together on the downstroke, but on the backstroke they delaminate, allowing them to open up like louvers and allowing the wind to pass through them. This means there's a lot less resistance on the backstroke. Basically, this bird wing is a biomechanical check valve. That's amazing. I've never thought about it.
Doesn't he sound like an engineer?
Video in Peru on the macaws for the first time. This is why I've never seen it. Look how fast it happens. There's no way I could have observed that. But watch the macaws at high speed, and you can see for yourself clearly the feathers.
Vanessa, would you turn the light off, please?
On the
Thank you.
downstroke, you can see that all the feathers are lapped in such a way that they provide a firm boundary layer that air can't pass. But on the upstroke, look what happens. You can see that the wings separate and the feathers turn so that the air is flowing straight in between them.
You can see through the wings.
Straight through the wing.
Isn't that a trip?
Amazing. So he has a lot less resistance.
Did everybody see it?
Because the downstroke. Another thing he does to decrease this resistance on the backstroke is he's performing more of an elliptical sweep with his wings instead of just an up and down flap. So what he's doing is, on the backstroke, he's pulling that wing in, and he's decreasing the length, so he decreases the surface area of the total wing. That's pretty awesome as well. So one of the coolest misconceptions I had is pretty clear to see on this red macaw. I used to think that birds just flap down and they create high pressure underneath them and they push themselves up. But if you look at this macaw, something else is happening. Look at the back of his wing here. You can see that the feathers are being lifted up on the downstroke. What that means is we have a low pressure situation there. It's like in engineering when we use something called computational fluid dynamics. Basically what we do is we analyze the flow field and we figure out what pressure situations we have at each location. Now you know that on an airplane wing we have a low pressure situation on top. That's exactly what's happening with this red macaw. So look at his wing and you can see that not only does he have a high pressure situation on the bottom, but the low pressure is so great that it's pulling those feathers off of his wing. That's amazing. So not only is he pushing down, but he's being pulled up on the same stroke. That's pretty awesome. Now this green parrot's doing the last thing that I thought was pretty wild. If you notice, he is angling the tips of his wings on the backstroke and pushing back behind him. So he's providing thrust. But one thing that's happening that I don't really understand, but it looks like it could be true, he's breaking his wing in half between the secondary and primary feathers, and he's angling it, and it looks like he's diverting that flow down, almost like a vertical takeoff Harrier jet. It's pretty cool, and I think it could be happening, but I've never actually thought about a bird being able to provide downward thrust on a backward stroke. That's pretty wild. So I thought I knew how flapping flight works, but clearly I didn't. Send this to any of your buddies that like think critically because they'll do what I do now. Every time I see a bird against the sky, I watch his wing, and on the downstroke, right at that point where he's pausing to transition back to an upstroke, if you watch, you can see sunlight pop in between the feathers because he's opening it up for lower air resistance on the backstroke. And I think that's awesome because now I know how bird flight works. Anyway, I'm Destin. You're getting smarter every day, and I'll leave you with this picture that my daughter made by gluing homing pigeon feathers to a piece of paper.
Sounds like a homeschool dad to me.
You're getting smarter every day. Have a good one.
Yeah, at the end, he takes his boy out and does birds.
What are we going to do here, son?
Let this bird go.
We're going to let this bird go. But before we let the bird go, we're going to talk about his feathers, aren't we?
Okay, so we already did that. Wasn't that cool? So when I found out, I thought, we got to watch that. So, okay, let's go back where we're supposed to be. There we go. All right, another thing that helps birds fly is that they have very light bones. And I have for you, this one's not as clean, so it's in a plastic bag. Okay. This one is cleaner, so just don't lick it and you'll be fine. If you want to actually see in a bird bone, there is a crack on this side that you can look in it and actually see the structure, the air-filled structure. But I want you to feel them both. Notice they are approximately the same size. I know when I handed this to the guys the other day, they went, wow! I mean, it's an amazing difference in how much they weigh. So just pass those around together, please, so you can compare them and then pass them on. My dogs were kind enough to bring me that other bone. And I found the vulture bone on the beach once, and you know me, I was like, oh, goody! So everybody else was like, you're such a sick person. Anyway, okay, so the skeletal structure of a mammal bone or a reptile bone is a much more solid, whereas the bird's bones have a lot more air in them. They still have the strength. And it talked about this, that when they were actually building planes, they were making them too heavy, and then when they made them lighter, they were breaking apart and falling apart. Then they went back and looked at the bird's bones again, and they found that they had these like hairs of bone going through them, but there were a lot of air spaces, and that gives them the strength that they need without adding the weight to them. And they mimicked that in the airplanes, and I think they were called Warren, I can't find it in here. Let's see. And see, I am so not an engineer, it's not even funny.
Warren's trusses.
Yeah, where are you?
513, bottom of the second paragraph.
Okay. Yep, there it is. Thank you. I always got the Warren right. Thank you very much for that help. Warren's trusses. And so they use that design feature to make airplanes stronger now. Isn't that amazing? It really is. That's why I brought them, because when you feel them, it's like, oh my gosh, you know, it's just amazing how different they are. Anyway, okay, then we get to class Mammalia, which is us, mammals, yes. Okay. Oh, and those of you that want to see on page 514 and 515, there's all sorts of different birds that he's got there. I want to point out that the ostrich, the emu, the penguin, they all have the heavy bones because they run, they need the strength, or they swim. The penguin is perfectly designed to swim. They don't fly. They were never designed for that. Their wings actually function like flippers in the water. They're tremendous swimmers. As a matter of fact, they've used their shape of their body to make more efficient cargo ships and things like that, because they have such a, I want to say aerodynamic shape, but there's probably a water word for that, fluid dynamics or something, I don't know. But it's very efficient at how it passes through the water. And then if you ever want to have some fun, look at hummingbirds, because hummingbirds can actually fly backwards, forwards, up, down, sideways. Until we came up with helicopters, we had nothing that we knew of that could move like a hummingbird can. And their wings beat at something like 70 beats per second. You get a grip on that for a minute. 70 beats per second. That's why they're called hummingbirds. Their wings hum because they're moving so fast. I don't know if you knew that. And they actually use so much energy that they go through something called torpor, which is like a suspended animation that they go through when they're not actively gathering nectar they are basically in a coma. Because that's what torpor is. Kind of like us after a game or something, right? Okay. Or me on Friday. They're very, very interesting. And then it went through, oh, it did mention one other thing that would be worth mentioning. It talked about the game birds and how they have white meat. Did you read that part? And if you've ever, like some of you like dark meat, some of you like white meat, but if you're getting a chicken or a turkey, those are all birds that don't fly a lot. If you've ever been around somebody that raises chickens or turkeys, here, I'll get it. Here we go, this way, thank you. There you go. It's not dirty, don't worry. I put the dirty one in a bag. I didn't quite know how to clean it, that's why I just stuck it in a bag. My dogs cleaned it that far. When I first saw it, it had meat on it and skin still. And then I waited a couple days and it got down to that and I said, okay, it's mine. I took it from them, so I don't know where they get the things they do. Anyway, if you've ever seen a turkey or a chicken, you know they don't fly very far. Or a quail, they don't fly very far. And if you've ever eaten one, and I know everybody here has at least seen a chicken or a turkey being eaten, even if you are a vegetarian or vegan, you know that the breast meat is white meat and that the legs and the thighs are dark meat, right? How many of you have ever seen somebody that ate a goose? Goose. Oh my goodness. My dad went to South America hunting to shoot geese with a friend like once or twice. He goes, you want some goose breast? And I'm thinking, wow, this is, you know, meat and its breast. Sure, Dad. And he gives me this meat and it's dark red like calf's liver. And I went, what's this? He goes, that's goose breast. Huh? Well, geese fly long distances. And so their muscles in their chest have to have a lot more myoglobin in them, which is the chemical that is in muscles to hold the oxygen. And therefore, their chest is dark, and it makes a chicken's dark meat look wimpy white. Okay, I am telling you. Because a chicken, the reason his leg and thighs are dark meat is because he runs around. So those muscles have more myoglobin in them than his chest muscles. Therefore, they look darker than his chest. But that chicken ain't seen diddly until he's seen a goose. I'm telling you. That goose, he's flying hundreds and maybe even thousands of miles in some cases. So they are red, like beef. Like beef liver. I'm telling you, it looked like beef liver. That's how dark it was. I never did end up eating it. Freaked me out too badly. Anyway, my dad's like, make pate. I don't think so. Okay, so we dealt with that. Swimming birds, we all know about those. So let's go over to mammals. Mammals, they're not just on land. They're also in the water, aren't they? And the things that they have in common is they have hair on their skin. That includes whales. I know, pretty weird. They reproduce internal fertilization, and they are usually viviparous. Who can remember? What does viviparous mean?
Live-born.
Good, it's live-born from a placenta. Remember, that means that it has a belly button because it had an umbilical cord attached to mama through the placenta. And so that would be your viviparous individuals. We do have some oviparous mammals, and which is your duck-billed platypus and your echidna. We're going to talk about those in a minute, which are anteaters, in case. I didn't know an echidna was an anteater, and then I saw someplace else, it's a spiny anteater, and I'm going, oh, that explains it. And then the other are marsupials, which are your kangaroos and opossums and things like that. So those are the ones that aren't like that. Mammals nourish their young from milk that's produced in mammary glands. This includes whales and dolphins and all those guys. Okay, they actually nurse underwater. And then mammals have a 4-chambered heart, and mammals are endothermic. And I just remembered what I forgot to tell you because I didn't have a, yeah, I do have a slide for it. Never mind, when I get there, I'll tell you. Okay, sorry. So they have these things in common. You guys know you're supposed to know that for your test. One of the things is that it tells us that hair is grown in follicles. And I know this picture shows you a healthy follicle and an unhealthy follicle because it's from WebMD. Just let it go. But the follicle is this part that the hair grows in. And once again, a feather is more like that, where it's actually got a structure that it grows out of. So for this to have just happened from a scale would be a rather interesting thing. know it sounded like there were rats up in here before. Seriously. You think that's it? Okay. Not aliens, not rats. Okay. And you heard it too. Okay, good. I just wanted to show you, look at the hairs on this. This is the southern right whale, which is a large whale, a really, really large whale. But look at the hairs on his face, okay? Because I looked up whale's hair, you know, and that's what came up. So anyway, I just wanted to show you. It tells us that mammals have two basic types of hair. They have the underhair, which has to do with insulation predominantly. And then the guard hair is the hair on the outside. That's the one that is used more for camouflage, weapons, or sensory. Now, what are we talking about by a weapon? What animal uses its hair as a weapon? And we're not talking girls, guys, so don't go there. Okay, come on.
Porcupine?
Porcupine, right. Porcupines use it, and I think maybe the spiny anteater might too, because he's got some spines going on there. So it probably keeps some things off of him because he's so spiny. Hey, how about a hedgehog? Some people have pet hedgehogs, right? So that might be how I could use them. And I could think of another way. When your dog sees somebody he doesn't like, their hackles go up, right? Have you ever seen that? Where the hackles go up? You've never seen that? The hair actually goes straight up on the back, going down the back of the dog, and they're ready for attack or flight at that point, and they're like super sensitive. So anyway, okay, so guard hair and underhair. And if you live in South Florida or someplace hot like this and you have like a husky or a Malamute, the idea is that in summertime or in the spring you actually comb out the underhair so that it cools the animal off. I know there's still probably some there, but it's supposed to insulate them both ways. I know this is a little gross. It was the nicest picture I could get for you of a placenta, okay? So this baby, for some reason, excuse me, Massachusetts, I don't even know anybody in Massachusetts. Just stop. Okay. This is the placenta. You can see where it attached to mommy, and that's where the nutrient exchange and gas exchange occurred. And then it went down the umbilical cord into the baby, and that's where our belly button is, because when that becomes detached, that would be the belly button. All mammals that are placental mammals have a belly button. That means if you go home and flip your cat over, you can find the belly button. If you flip your dog over, got to rub their tummy first, but then you can find their belly button too. Don't rub the cat's belly. They get a little weird, especially if it's got claws. You might lose a hand. Your horse, they have belly buttons. Whales have belly buttons. All of these placental mammals have belly buttons because they were attached to mama through the placenta and into the umbilical cord. There were some words we had to know here. The placenta, I showed you that, and that's where the baby is nourished through the mother's blood supply. There is not supposed to be a crossing over the blood between the mother and the child. Now, not supposed to, in reality, are different things. And sometimes, if there is a flush of blood from the baby back into the mother's body, and the baby has a different blood type than the mother, then her body can actually make an immune response against the baby. This usually happens with an Rh negative father and an Rh positive father, Rh negative mother. Okay, so 80% of the time the child has the Rh of the father. And so let's say her baby's Rh positive, but mama's Rh negative. If any of that blood is backflowed into her body, then her body will make an immune response to the Rh positive antigen flag on the cell. And then if her next baby is Rh positive, her body can attack it and kill it. And that's why here in the United States, if you're an Rh negative woman, they will give you something called microrogam to take those antibodies against your, possibly take, you know, if you have the antibodies against your baby, they will actually give you something that takes those antibodies out of your system so that your body won't attack your baby. Just so in case you ever hear that, okay? Gestation is the period of pregnancy. It's how long it takes for the baby to cook. So that means for dogs, 60 days. Cats, 60 days. Mama horse, 11 months. Poor mama horse. Mama elephant, 24 months. Poor mama elephant. Okay, so, I mean, that's a long time. Gestation, though, varies, and usually the longer an animal gestates, the more developed they are when they're born. Think about a baby elephant or a baby horse. When the baby elephant or baby horse is born, they stand and they walk and they run very quickly, don't they? And they have to, otherwise they're going to be panther food or lion food, depending on where they live, right? So they have to get up. I don't know if you've ever heard how a mama giraffe does it. Oh my goodness. Mama giraffe, the baby drops from like 6 feet high because she stands when she gives birth, unlike these other animals. And the baby literally falls 6 feet to the ground. Smack! Okay? And then mama giraffe doesn't end the tough training there. Then she starts kicking the baby. And she kicks the baby till the baby gets up. And then once the baby's standing up, she kicks it and knocks it over again. And then she starts kicking it again. Get up, get up, get up. And I know we all think, boy, that's a mean mama. No, mama knows lions like to eat baby giraffes. And mama tough trains that little dude to get his butt up so that he doesn't end up being lion food, okay? But when I heard that, I was like, oh my goodness, that is amazing. I wouldn't want to be a little giraffe. That's just tough, huh? Anyway, once they get up, and mama doesn't beat him up anymore, or let's say, well, let's go back to the baby horse, because I like those a little better anyway. Mama horse nuzzles a baby. She licks it all over. Baby horse gets up. He does this. You ever seen the movie Secretariat? You've seen that, okay? He does this, and he stands up, okay? And then they go over and they nurse from the mammary gland. So I found you a cow, because I figured nobody'd get offended if I showed you a mammary gland on a cow, okay? Because we see these all the time, don't we? And so the mammary gland is where the mama mammal makes the milk, and then the baby drinks the milk, and that is called, actually it's called parturition, which is not in your book. We used to breed horses, and you have to feed the horse differently while they're nursing parturition because they're supporting both of them. And we were breeding racehorses, so you wanted to have very healthy bone and stuff, so my husband knew all that stuff. Anyway, so, and I imagine it's true with a cow too. You know, anything that you're trying to grow well, you would want it well fed. If you're a mother that has a baby, you want to try to eat well so that your baby has the best nutrients it can while you're nursing the baby, because that's what it's eating. Now, those are for normal placental mammals. We also have not normal, no, we have mammals that aren't placental mammals. The first one are monotremes, and these are your egg-laying mammals. Once again, this is a spiny anteater, and the platypus are your examples. I think the fun one is the platypus, and the platypus, he is just such a strange creature with the duck-like bill, the beautiful coat. The male has venomous spurs. They swim through the water, and then they don't actually have mammary glands on the outside, but they have them, and they make milk, and the milk is just oozes onto its fur, and then the baby just laps the fur off with his little bill. Because think about it, could this little billed animal actually grab hold like a calf would on the mammary gland? No. So God made it so he can just lap the milk off of the fur. Is that amazing? So that's the closest I could get to platypus nursing. That was what I could find for you, okay? Anyway, and then the other non-placental mammals are marsupials. And marsupials are pouched mammals. Pouched mammals, okay? And so what do you think of immediately when you hear of a pouched mammal? Kangaroo. We all think of kangaroos because that's where we go. Another really cute one is the koala bear. Koalas actually are a pouched mammal, and they have little baby koalas that'll hang out there out of the pouch, you know. But I wanted to, oh, that's our version. Most marsupials live in where? You tell me. Australia. They got almost all of them, but we got possums. Now, I know if you're doing it correctly, it's an opossum, but no self-respecting southerner walks around going, opossum. It's a possum, right? I don't eat them, but it's a possum. And mama possum has baby possums, and they go into her pouch. I think I told you guys, when my current puppies were puppies, real puppies, they were devil dogs. And I found a little possum on the front porch when I went out to feed the horses. I heard something, and I turned around, and there's this little damaged possum on the front porch, about that long without the tail. And I know most people hate them. Even in my family, they, oh, kill it. And I'm like, no, it's a possum. It's fine. They don't like me. I don't like them, but I don't want to hurt them. And I look at this little possum, and I made the dogs go away. And she had managed to get hurt and get up on the front porch and hide in the stuff on the front porch to get away from dogs, so you can tell the station of my house, you know, that there's stuff on the front porch so they can hide behind. But anyway, shh. And I wanted to get her help, but you know, they're a wild animal. You never touch a wild animal. You guys know that, right? Never touch a wild animal, and never touch a scared wild animal, because they will hurt you because they're scared, and they have every right because they're scared. And this poor thing was damaged and scared. Long story short, I backed her into a box. I put a box behind her, got something in front of her, and made her back up into the box, flipped the box up, carried her to the Conservancy. They got to see me a lot at that period of time. I used to bring them so many animals, but anyway, they either thought I was a really great person rescuing all these animals, or they wondered why I was hurting all these animals. Anyway, I take it to the Conservancy. I said, can I call to make sure it makes it? It was a little female, and she had 4 babies in her pouch, and I never even saw the babies. But they saved them all. I was so glad, because my husband's like, it's not going to make it, just leave it alone. I'm going, no, 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 no. So I drove into town, half-hour one way, took it to the Conservancy, and they fixed her. And in the Keys, I saw a mama. In the Keys, think about it, there's people everywhere. I saw this little mama possum going across, and there goes 6 little babies behind her, about that long. Little babies, and I'm going, oh my goodness, and this is in a neighborhood. They're just, so possums are cool. Anyway, I want to show you how this works with marsupials, because remember we just talked about, like, if you've ever had baby bunnies or baby mice, you know that they're not pregnant long. Never had babies? No? Most homeschoolers do that kind of thing. You have a baby, like guinea pigs or bunnies, and have babies, and mom goes nuts, and then she gets rid of them all. Anyway, they're born with their eyes closed, no hair on them. They're very not developed, okay? But they're super developed compared to marsupials. Now I got to show you this, because this is worth you seeing, kind of like the other. And it's by National Geographic, so it's pretty good. And it's short, but I remember the first time I saw this, I was so amazed about how the birth of a kangaroo.
Almost a year. But how it gets there in the first place is a strange and harrowing journey.
Watch this. About that long.
At 1 month old, the baby roo, barely more than the size of a jelly bean, emerges from one of its mother's 2 uteri.
The only thing it has, no back legs, it just has like this on the front.
Her fur. And though it still hasn't developed eyes, it instinctively relies on its forelegs to crawl up towards her pouch.
Look, it doesn't have any hind legs. Did you see that? It's not developed that far yet.
A few minutes for the tiny roo to reach the pouch.
It's got to climb all the way up, or it dies. If it falls off, it's dead.
In minutes, it reaches her pouch and latches on to its mother's teat.
And then it starts to grow. See? So what we would develop attached to the mother through the placenta, they actually do it in the pouch. Okay.
Over the next few months,
just
it grows.
Because of time, we're going to cut that off. Vanessa, would you turn our light back on, please, sweetheart? Thank you. What I wanted to show that to you for is because what we would do in the gestation process as a placental mammal in the mother, they do in the pouch. But that little baby marsupial has to climb up to the pouch, and if it falls off, it's dead. You got to start over. It's gone. Mama can't help it. And it has no eyes and no back legs, and it just does this climbing up the hair, gets in the pouch, has to find its way down to the mammary gland, attach itself, and then it would continue development like we would develop inside the mother, which is amazing in my mind, okay? Now, what's really a trip, okay, mezzotherms, I told you there's cold-blooded animals that are totally dependent upon. You know what, I want to do something else first. These are in between. I'll just say this. We regulate our body temperature. Cold-blooded animals are totally regulated by what's going on in the environment around them. Mezzotherms are not warm-blooded, but they can actually, through muscles, stimulate a certain amount of heat in their body. Tunas, sailfish, marlins are like this. The leatherback turtle and the echidna are all mezzotherms. And think about it, that's a mammal, okay? And they say dinosaurs, they think now we're mezzotherms, but they're not sure. Now, this is what I really wanted to get to with you. In the marsupials, the pouch is called the marsupium, okay? Marsupials, it's very interesting that there seems to be animals that are not marsupials, that are placental mammals that look very similar to The marsupials. So the evolutionists say this is because of something called convergent evolution. Now, convergent evolution, here, and I even got you a slide. Convergent evolution says that they have similar features because they evolved in similar habitats. That is the most amazing thing I've ever heard, because that means everything had to evolve twice. The statistical chances of them evolving once is totally astronomical, but for them to have evolved twice is even more ridiculous, if you'll think about it. And so the example they give is the ichthyosaur and the dolphin, or they actually put the ichthyosaur, which is a marine reptile that's dead now, dolphins and sharks, and they'll say those are all convergent evolution. Those things were similar. They lived in a similar habitat, so therefore they evolved similar structures. The other thing that would be a good example of convergent evolution would be wings. We have wings on insects, wings on birds, wings on bats, wings on pterosaurs. They had to evolve 4 different times. That's what they're saying. So when you hear convergent evolution, you'll know that that's what they're talking about. And then lastly, I want to end with marine mammals. Marine mammals they have fur, they have hair of some sort, they nurse their young. The baby whales, whether it be a toothed whale like a porpoise or a baleen whale, when that baby comes out, the mama and its group in the pod will actually push the baby to the surface to get its first air. And then it will come down and start nursing. It holds its little breath and starts nursing. And the same would be true of a manatee. But these diving mammals, this is what I wanted to point out to you, because if this stuff all just evolved, I want you to listen to this. These mammals, some of them can dive over, look at that, that's over a mile deep. That's 1.5 miles deep, okay? They'll hold their breath up to an hour at a time. They are designed for diving. They actually exhale when they dive, whereas we inhale, don't we? They exhale to get the air out of their body so they're less buoyant. The blood stops going to peripheral areas and goes to their brain and the muscles they need for the diving purposes. It doesn't go to their digestive tract or anything. It actually shifts where the blood is going. Their muscles actually contain more myoglobin than ours do. Therefore, they can hold more oxygen in their muscles. Their blood actually has more hemoglobin, more red blood cells, like a lot more red blood cells than ours do, so they can hold more oxygen in their red blood cells. Their chest cavities, their rib cage collapses as they get down there so that the air doesn't actually circulate in their body from their lungs, so they don't get the bends by going down and coming up quickly. And it makes them less buoyant so they can get down there. I mean, I could just go on and on and on about these design features that we see in these marine mammals, and yet an evolutionist wants us to believe that they came from some kind of a land creature and that it just decided to go back in the water and develop these features. Don't think so. Anyway, okay. So you're supposed to take your last test. And then you're done for the summer. Yay! Snippy dance. So we got through biology together. Praise the Lord. All right. All right, you guys. Have a very blessed summer.